So, hi everyone, my name is Nur Aladanisha and I'm going to present my question 1 of CBT for Life Contingencies 1 module, which I'm taking this semester. So, let's begin. I will start by explaining about the question. So the question asked me to choose one country to work on individually, and I choose Switzerland. Then I collected the death rates data from Switzerland in 2020 based on the website provided by my lecturer. In part 1, we are going to construct a life table similar to the illustrative life table for Switzerland in 2020 with interest rates of 5% and 6% per annual. We are making a life table for basic pensions and single benefit premium at respective interest rates for part 1. Next, for part 2, we are constructing a life table commutation functions at the same interest rate of 5% and 6% for dx, nx, sx, cx, mx, and rx, which is the representative for the function from the illustrative life table. And lastly, we are going to construct, in part 1, part 3, we need to make a table of tabulating functions for the same interest rate, including increasing annuity due function IAX, increasing whole life function, and also EX, which is the curtailed expectation of life at HX. Hence, we will answer each part of question 1 in detail. I imported the number of population at each X in 2020 from the website of mortality.org. So I highlighted the detail, which is Switzerland, and then we are going to look into the data from 2020 only. So we will start from the age of 0 at 100,000 LX until the age of 110 at the end of LX equals to 2. So yeah, we are going to look into the part 1 of question 1. This is the example of how the illustrative life table looks like. We are going to find each formula for the function in Excel sheet. Same goes to part 2. Here is the example of the life table for the commutation functions that we are going to look into. Moving on to the next page, we also have the example of table of tabulating functions, and we are going to see the formulas that are used to find the respective values of these functions relating to data from previous part 2. So, we will look into the question 1 part 1 first. So, here is the rough formulas that are used to find the functions values. I put the column for each x at both sides of the table for convenience. Question 1 part 2. So, for the commutation function, we are looking into formula of commutation functions as you can see in the table shown here. So, for the last table in part 3, we are going to find values of 3 functions such as IAX, annually increasing annuity whole life insurance function, and also IA_X, the present value of arithmetic increasing annuity due function, and also EX, which is the curtailed expectation of life at each X. So now I'm going to demonstrate the function in Excel sheet. Question 1, part 1, which is the illustrative life table of Switzerland in 2020 for basic functions and single benefit premiums at interest rate equals to 5%. So the table for the basic function and single benefit premiums at interest rate of 5% and 6% is similar. It's just I use different value of I, which is 5 and the other one is 6. So as you can see, here I put the value of the column of x on both sides so that I can find the value of the functions easily. So I put the value of x from 0 until 110, which it actually represent the age of the value that we are looking for. So Lx is the expected number of person who can survive from each x. It's the expected number of person who can survive to each x, and then next we will find the value of 1000 qx. So as we all know, qx the formula is equals to 1 minus bx. So here to find the value of 1000 qx, I multiply 1000 with the formula of 1 minus lx plus 1 over lx. So next we will find the value of annuity due function a_x. So the formula that I use is 1 minus ax over d. So I use the value of 1 minus 1000 ax over 1000 divided by d, which is equal to 0.05 over 1.05. And then to find the value of 1000 AX, I use the value of 1000 multiplied with V, which is equal to 1 over 1.05 times with PX plus, sorry, I use the formula of V times with QX plus PX times with AX plus 1. So the value of AX that I use here, I divide by 1000 since I only have the value of 1000 AX. And then moving on to the next column, which is we are looking into the value of second AX times with 1000. So to find 1000 of second moment for the whole life insurance, I multiplied 1000 with the same formula to find AX, but I just powered by 2 the discount factor, which is V equals to 1 over 1.05, and then the rest is the same, which is QX plus PX times with EX plus 1. I mean second moment of EX plus 1. Okay. And then to find the value of 1005 EX, I use the value of 1000 multiplied with V power of 5 times with LX plus 5 over 5. LX plus 5 over LX. And then similarly, to find the value of 1010 EX, I multiplied 1000 by V power of 10 times with LX plus 10 over LX. And lastly, for the basic function and single benefit premiums table, life table, to find the 1020 EX, I multiplied 1000 with V power of 20 times with LX plus 20 over LX, which is from this example here, you can see the L20 divided by L0. Okay, then I got the value. So that is for part 1, which is to find the life table that imitates the illustrative life table. And then similarly for life table at interest rate equals to 6%, I just use the value of I equals to 0.6. So you can see here. So the value to find the annuity due function, I use the 1 minus 1008x over 1000 divided by the value of D, which is 0.06 over 1.06. Then to find the value of 1000 AX, I use the value of 1000 multiplied with V equals to 1 over 1.06 times with PX QX plus PX times with AX plus 1. So moving on to the value of second moment of whole life insurance AX times with 1000. I use the formula of 1000 times with V power of 2 and then times with QX plus PX over second moment of AX plus 1. Then to find the value of 1005 EX, I just change the value of I. So now I use the value of 0.06. And to find the value, we use the formula of 1000 times with V power of 5 divided by LX plus 5 over LX. Same goes to the 10 EX and also to find the value of 20 EX. I just change the value of the value of I, which is now is equal to 0.06. So moving on to part 2, which is the computation functions for the illustrative life table. At I equals to 5%, we are looking for the value of dx, nx, sx, cx, mx, and also rx. This is the formulas that represent the functions from the basic functions and single benefit payments. This one. Okay. So here, as you can see, I also make 2 tables, one for interest rate at 5% and also one for the interest rate at 6%. So the value is also from x0 until 110 for both. So now let's get into the formula. So to find the value of dx, I multiplied the value of v power of x with the value of lx from the table here. Lx from the basic function life table. So from that, the value we can find, which is 1 over 1.05 times with the power of x equals to 0 times with Lx equal to 0 for the first column, for the first row. And then to find the value of nx, I just add up the value of dx with the nx plus 1 value. And then to find the value of sx, I just add up the value of Sx plus 1 with the value of Nx. Next, to find the value of Cx, I use the formula of V power of x plus 1 times with Lx minus Lx plus 1. So here, the value of V is equal to 1 over 1.05 times with x plus 1 times with Lx minus Lx plus 1. So here. And then moving on, to find the value of Mx, I use the formula of dx minus with d times with nx. So dx here, dx minus with d equals to 0.05 over 1.05 times with nx. And then to find the value of rx, I use the formula of nx minus d equals to 0.05 over 1.05 times with sx. And then same goes to the commutation function table at I interest rate equals to 0.06, which is 6%. So I just change the value of I to 0.06 to find the dx, and then to find the cx, we also change the value of I to 0.06, and then also to find the mx, since the value of d now equals to 0.06 over 1.06, and also rx now is equal to 0.06 over 1.06. Okay, here is the value that I got from the functions that I use for both. Okay, for the last part, which is the part 3, now we are going to find the value of three functions. So to find the value of IEX, I just divide the value from the table of commutation function dx rx divided by dx, and then we can find the value of ie double dot x by using the formula we derive from the commutation function table, which is xx over dx. And then next, to find the value of ex, I use the formula of 1 minus px times with to find the value of ex, I use the formula of px times with 1 plus ex plus 1. So the value of px, here I use the value of dx, so to find the px, I use 1 minus 1000 qx over 1000 times with 1 plus ex plus 1. So this is the value that I use, 1000 qx. That's why I minus 1 minus qx to find the value of px. And then same goes to the tabulating function like table for I equals to 6%. And then, so for this table, we also find the value of each x at value of 0 until 110. So I think that's all from me. Thank you. Present my question 3 of CBT for Life Contingencies 1 module, which I'm taking this semester. So let's begin. This is about question 3. I will start by explaining about the question. So the question mentioned that Azriel Life Insurance issued a number of 20-year endowment policies to a group of individuals aged 45 on January 1, 2005. In each case, the sum assured was $200,000 and premiums were payable annually in advance. So mortality is based on the constructed life table and the interest rate is 4% per annum. So the question asked me to calculate the net premium reserve for the years ending in 2016 through 2022 in part 1. And for part 2, on 1 January of 2021, 600 policies were still in force during 2021 and 2022. 7 and 8 policyholders died respectively and no policy lapsed for any other reason during these 2 years. Calculate the mortality profit or loss for this group for the year ending in 2020. So, in this question, we are going to use the data from the illustrative life table of Switzerland in 2020, which the basic functions and single benefit premiums at interest rate equals to 4%. From this data, we can find the value of functions that we need to use to find the final answer later. I draw a timeline of the life insurance policy. As you can see, the T, which is time, is from 0 to 20 as the policy issued from 20 years starting on 1 January of 2005 until 31 December of 2025, which consider which ends on 1 January of 2026. Yes. And then the policy also started for a group of individual age 45 initially, so the value of X range from 45 to 65. Additionally, the premium labelled pi is also payable annually in advance, so policyholder will pay premium starting at T0 until T19. For the sum of death and survival benefits, they will receive $200,000 after a year on T1 when they age 46 until T20 at the end of the policy period when they age 65. So they will get the benefit each year. Okay, so this is about the question 3. And then moving on, this is the formulas that I used to answer question 3 part 1. So from the formulas that I gave before, now we can find the value of level premium. As for this question 3 part 1, the APV future benefit at age 45 is $200,000 times with N year endowment insurance A45 to 20, and the value of A45 to 20, the endowment insurance value is the value that we are going to find later by using the Excel. So now I'm just showing you the rough calculation, the working. And then to find the APV of benefit premium at age 45, I use the formula of pi times with annuity due 45 to 20. And then to find the level premium pi, we use the formula of APV future benefit divided by APV benefit premium. So which is the APV future benefit of $200,000 A45 to 20 is the life insurance of 20 periods when age 45, and the APV benefit premium of annuity due 45 to 20 is the annuity immediate of 20 periods when age 45. So next, this is the working of the rough working for to find the value of mortality profit or loss in question 3 part 2. Now I'm going to demonstrate the working in Excel to find question 3. So now we are going to look at the demonstration for question 3 in Excel. So before we find the value of net premium reserve, we have to construct the table for basic function and single benefit premiums at interest rate of 0.04, which is 4%. So I use the same formula from question 1 to find the value of each of these function. So same as question 1, we use the value of from x equals to 0 until x equals to 110. Okay, so now moving on to part 1 of the question. Here is the table to find the value of net premium reserve. And now, as you can see, the values that I put for year start from 2005, as the question start from January 1, 2005 until 2025, 20 years. Okay, and then for the value of n, we start with 20 and then decrease by 1 until it becomes 0 in 2025. So for the age, we start from 45 until 65, as mentioned in the question, and then to find the value of NPX, we use the value of Lx plus n over Lx. So to show you the example, to find the NPX at age x equals to 45 and n equals to 20, we use the value of L65 divided by L45. And then this formula is applied for the rest of NPX at the various age and n. Okay, and then to find the value of NEX, we use the formula derived from NPX but times with V power of n. So the V is equal to 1 over 1.04 power of n, which is 20, times with NPX. And then next, we are looking at the value of annual term life insurance. So the value, to find the value of annual term life insurance, we use the formula of 1000 EX divided by 1000 minus with the value of NEX times with EX at 65. Okay, so basically the formula we use is the general formula that we use is EX minus with NEX times with AX plus N. Okay, and then next, moving on to find the value of N-year endowment insurance, we add up the value of N-year term life insurance with the N-year pure endowment formula, which is also equal to NEX. So EX to N1 plus NEX equals to the N-year endowment insurance. Okay, then next we find the value of actual present value for benefit, which is the future benefit at each year. And then so to find the value of APB future benefit, it is the value of 200,000 times with the same N-year endowment insurance formula. And here I just use the formula of N-year term life insurance plus with NEX times with $200,000. Okay, and then to find the value of annuity due X to N, I use the formula of 1 minus N-year endowment insurance divided by D, which is D is equal to 0.04 over 1.04. So by using the formula of annuity due, we can find the value of APB premium, which is the actual present value of benefit premium at X to N. So we multiply the value of annuity due with the level payment. Okay, so now I'm going to show you, before we just find the value of premium reserve, I'm going to show you the formula to find the net level premium, which is also known as Y. So as you have seen before, this is the formula to find the APB at future benefit at age 45, which is equal to $200,000 times with the annual endowment insurance at E45 to 20. So the formula to find the 20-year endowment insurance at age 45 is $200,000 times with E45 to N to 20. Okay, and then same goes to the APB of benefit premium at age 45, which is equals to 5 times with annuity due at age 45 for 20-year policy. And then this is the value, which is I already found in the table above. Okay, here, and then we can directly find the value of pi, which is level premium, by dividing the formula of EPB future benefit with the annuity due at age 45 to 20 years. Okay, so by dividing the value, okay, EPB benefit with the annuity due at age 45 to 20 years of policy, we can find the value of level premium of $6,688.84. Okay, so by using this formula, the value of level premium pi, we now can find the value of premium reserve. Okay, so to find the formula of premium reserve, the question only asks from 2016 until 2020, right? But we are going to find just for all the year of the policy, 20 years. So to find the value of HB, the premium reserve, we minus the premium APB premium with APB benefit. So APB benefit minus APB premium, we will get the premium reserve. So now the question asks for the net premium reserve for the years ending in 2016 to 2022. So I highlighted the values here. Okay, and then so that's all for question 3 part 1. Moving on to question 3 part 2, we need to find the mortality profit or loss for 2021 and 2022. So the premium reserve of 2021, which is also equals to 16B, as I've shown from the rough formulas before. This is the value. Okay, we take from the table. Okay, so now we can find the similar for 2022. We just use the premium reserve value of this one, okay, to find the HP. Just to put here and then to show you. I just want to show you, okay? And then to find the value of test rate, it is the negative value of premium reserve. So just add up the negative sign, and then we can find the ADS, which is actual test rate of the test rate times with the number of people who died during the year. So in 2021, 7 people died. So we times with the test rate, okay, to find the value of this one. Okay, to find the value of ADS in 2022, 8 people died. So times with the death rate, we get this value. Okay, to find the value of expected death rate, the value is a little bit different. So here we times the number of policies available which is still in force, which is 600, times with the value of Q65. Okay, now I'm showing you the Q65. Okay, we need to divide by 1000 since the formula table is 1000 QX. Okay, and then times with the value of that rate. So, and also for 2022, 600 minus 7 since we minus the 7 people in 2021, so only the remaining left in 2022 for the number of policies, and then times with the same formula Q60. I'm sorry. Okay, so we times with the value of each of the policy holder at 2022, which is 62. Okay, so for 2021, so they times with the value of each of the policy holder, which is 61, the Q61. Okay, so now we get the value of EDS and EDS. We can find the value of mortality, profit or loss. So EDS minus with EDS, we can find the value for both 2021 and 2022 mortality, profit or loss. Okay, so for both year, we get the value of mortality, profit. So as you can see here. Okay, so that's all from me. Thank you.